Welcome back. Today we will learn the final two shortcuts to prove triangles are congruent. The first one is called the angle side angle postulate, abbreviated ASA. It states that if two angles in the included side of one triangle are congruent to two angles in the congruent side of a second triangle, then the two triangles must be congruent. For example, if you're given that angle B is congruent to angle E, and angle A is congruent to angle D, and the side between those two angles, side AB and side DE, are congruent, then we can conclude that triangle ABC must be congruent to triangle DEF. Notice that if we look at this in order, this goes in order angle, side, angle. That's why it's called ASA postulate. Let's use this in a proof. So it says write a two-column proof given that segment QS bisects angle PQR. Angle PQR is this angle here. Bisecting means cut the angle exactly in half. So it's cutting this angle exactly in half. We are also given that angle PSQ, this angle, is congruent to angle RSQ, this angle here. We are trying to prove that triangle PQS is congruent to triangle RQS. So, since these two triangles are touching, it may be helpful to redraw it so that they're separate. It doesn't have to be a perfect drawing. Mine's clearly not. And obviously we'll want to label what we have been given. So, it says to use the definition of angle bisector. I know that it said QS bisects angle PQR. So I'm looking at angle PQR, and by the definition of angle bisector, remember we said it means that it cuts the angle exactly into two equal pieces. So we could conclude that angle PQS must be congruent to angle RQS. The reason I wanted to put point S last is because I know that it corresponds to angle S. On each one, I already know angle PSQ is congruent to angle RSQ. So I know angle S is corresponding. So I knew that I wanted to put it in the same spot. Next, it says QS is congruent to segment QS. I know that this is congruent to itself. Can you list this? Next, we will talk about the angle side postulate. It says that if two angles in the non-included side of one triangle are congruent to the corresponding two angles inside of a second triangle, then the two triangles are congruent. For example, if you have angle B congruent to angle E, angle A congruent to angle D, and one of the non-included sides, meaning it's not the included side, in this case such as BC congruent to EF, we could conclude that these two triangles, such as triangle ABC, is congruent to triangle DEF. Let's try using this in a proof. So I'm trying to prove triangle ACD this triangle, is congruent to triangle ECB, this triangle. Now this is one case where you will definitely want to redraw your two triangles. So I had ADC this was the green triangle, and the blue triangle is triangle EBC. Now let's see what we're given. We're given that angle DAC is congruent to angle BEC. You can label it in one diagram or both. At least label it where you drew it out separately, at a minimum. Next, we are also given that segment DC is congruent to segment BC. So I would like to mark that as congruent. Now we always want to start out with the given. So we'll start out by restating what we were given. Now I know the final statement should say triangle ACD is congruent to triangle ECB. Now notice that since these two are overlapping, they do share one vertex, C. Both triangles include angle C in their triangle. Angle C must be congruent to itself. That's called the reflexive property of equality. Property of congruence. Alright, so now that we have that angle pair congruent, notice that I have an angle, a side, and an angle. If we look at this in order, it's angle, angle, and a non-included side. Therefore, I can prove the triangles are congruent by the angle, angle, side congruence postulate. Alright, to conclude the lesson today, I'd like you to reflect, how do you know which method, side, 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 angle, angle, or angle, angle, side, to use when proving triangle congruence? What's the difference between these 4 different postulates? How do you know which one to use?